Okay, I'm now going to talk you through how to do the calculations for this lab. You have the data table, should have your data table set up, you should have your qualitative observations, and hopefully you have some numbers in here. Okay, so the next thing we need to do, if you think about all the pieces of our lab report, we've got the date, we've got the purpose, we've got the materials and the procedure, a quick summary of what we did. We also have our data table, we have our qualitative observations. So now it's time to do some math. So what I need you to do is go ahead and write calculations. So we're in a new section of our lab report. And whenever you do calculations, you always need to label them. Okay, so as a reminder, there are 4 different calculations that we are going to have to do. The first one is going to be the change in mass. Okay, now your change in mass is going to be delta, which stands for change. So you're going to have the final mass minus the initial mass. Now I know you may end up with a negative number and you're going to go, what the heck, how did that happen? Okay, what was the difference? And don't panic if it is negative. Okay, it is okay if it is negative. We're not changing the law of conservation of mass. It's going to be reflective of which way the energy went. So don't worry about it if it's okay if it's negative. Alright, so now what you need to do is either pause the video or leave yourself some space for where you're going to actually do your calculations in this space. Okay, so again, like I said, if you need to pause, however many trials you have, alright, if you have trial 1, you can do trial 1, trial 2, okay, however many trials you have, that's what you have to leave space for. And on the calculations, you'll notice we label it, we show the equation one time, and then we just have to do the work. We do not have to repeat the equation every single time. So that's going to be our first calculation. Our second calculation, so underneath there, the second calculation we have to do is the change in the temperature of the water. Okay, so for our change in the temperature of the water, again, we have to do the delta temperature is temperature final minus temperature initial. So we're still on the whole final minus initial thing. And again, you're now going to leave space for however many times, trial 1, trial 2, trial 3, and however many trials that you did. Yeah. Okay, so however many trials that you do, you're going to leave space and you're going to do all that math. Alright, then you're going to do calculation number 3 is going to be the mass in grams of the water, because if you remember, we need ultimately, why are we doing all this? Well, we need to figure out how much energy was absorbed. And if I just come back to this for just a second, I'm going to come back to my setup. Remember, the way that we determined the flow is that the energy was released by the food, it was absorbed by the water. So when we do our calculation of Q in our specific heat equation, we need to measure how much energy change there was in the water. So we have to know the mass of the water. Well, the easy part for that is that for the water, I'm going to write this out to the side. What do I know? Well, I know that I had 50 milliliters of water. Okay, I also know the density of water, this is kind of convenient, is that it's 1.0 grams per milliliter. Alright, so remember, we've seen this before where if you have the volume, you can use density to go to mass and then be able to solve in those math problems, and that's exactly what we're going to do. I'm going to go ahead and manipulate the density equation. Remember, density equals mass over volume. Well, if I remanipulate it here, the volume is always going to be equal to, no, okay, what I'm looking for is the mass. Okay, so if I come back to my density equation, remember density equals mass over volume. Well, I want to solve for mass. So in order to do that, anytime I want to solve for mass, I simply have to take the volume times the density. So if I have 50 milliliters, and you can see how these units cancel out, I then multiply that by 1.0 grams per milliliter. Okay, it's also kind of like a conversion, not to throw your brain there, but our mass is going to be 50 with a decimal place, 2 sig figs, grams of water. Now, I know all the other calculations, we've done trial 1, trial 2, trial 3, trial 4. Well, the good news for this one is that is it the same for every trial. So you do not have to redo it. Okay, it's done. There you go. Finito. All right, so we've got one more calculation, which is kind of the take-home message of this. Actually, no, I'm lying. Two more calculations. We got five calculations to do. Number 4 is practice with our heat. So we want to measure the heat, or Q, gained by the water. Okay, how do we do that? Well, we know, what do we know? All right, if I just list this out here, our unknown is Q. What do we know? Well, we found 50 grams of water. We found that from the last calculation. We know delta T for each trial. This was from calculation number 2. We also know the specific heat of water is 4.184 joules over grams times degrees Celsius. How do we know that? Well, I'm telling you that. The specific heat of water, again, is pretty high. This is the resistance to how much change in energy there will be. Okay, so then I've got Q is equal to the mass times the specific heat times the delta T. Now I'm going to trump sig figs here. What I want you to do, all of it, meaning that from over here you may only have 1 or 2 sig figs, I want you to have 3 sig figs for each calculation. Okay, so leave it as 3 sig figs. And now what I need you to do, we've done the known, we know what we're solving for, we've gotten the equation. I need you to do your work for however many trials that you did. So you're going to have work for trial 1, work for trial 2, however many trials you did, and make sure they are labeled so that I can follow them. Okay, now the very last piece that we have to do for calculation, so we've done the change in mass, the change in temperature, the mass of water, and the heat gained by the water. The last thing that we have to do, number 5, is going to be the heat, wow, let's try that again, heat per unit mass. All right, or in other words, how much energy is in the food. All right, that's what we're trying to figure out, is why were we doing this in the first place? We're trying to figure out how much energy is in the food. All right, so in order to do this, well, all that you have to do, heat per unit mass, well, we've already found Q for every single trial. This was your answer to calculation number 4. You also have the change in mass, which was your calculation from number 1. Now, remember, you may very well, and you probably, I don't want to say should have, most likely have had a negative number for your change in mass. And this is where it's going to be okay. You're going to do your math here for trial 1, however many trials again, trial 2, trial 3, trial 4, etc., etc. It's all going to be there. Don't panic if things are negative, because when you get these answers, all right, first of all, whatever you plug in, if you remember from before, your Q value was going to be in joules, and your mass value is grams. So your answer is going to be joules per gram. It's okay if it's negative, because if you remember, what we're trying to solve for is the energy that was released by the food. And since energy was released by the food, it's going to be exothermic. So that's where the negative sign is going to come into play. So it's not a big deal if you have the negative sign. Okay, so the 5th calculation, again, if you need to pause it, do trial 1, trial 2, trial 3, trial 4. You want to have work for all of them. Okay, so you want to go ahead and do your work or leave space for it. Now the very last thing that you need to do, which is what we typically do in quantitative labs, is you need to summarize the results in a results table. So all you have to do for your results table, remember there were 5 calculations that we just did. All right, so what I want you to do is go ahead and list those calculations out to the side. You have change in mass, you have change in temperature, you have the mass of the water, which remember is going to be exactly the same for all of them. You also have the heat, or Q, gained by the water. And lastly, you're going to have heat per unit mass, which, if you remember correctly, is going to be joules per gram. And what you need to do in your results table is summarize the results. Oops, and I'm not doing a very good job. You should probably use a ruler for your results table of each trial that you did. So if you have trial 1, trial 2, trial 3, trial 4, etc., etc. However many trials that you did, you need to take the answers to those calculations and plug them into your results table.